Division is probably the hardest area of calculating. We teach younger children to use repeated subtraction to divide. So with this example, we would ask them to take away 3 repeatedly until there was nothing left. Which would show them, in this example, that there were 5 lots of 3. Resources are often used, in this example, to take away groups of 3. And the language of sharing and lots or groups of is used a lot. Arrays are also used to help younger children, or older ones still struggling, to see the relationship between division and multiplication. With larger calculations, for example 72 divided by 5, we continue to teach the children to subtract, but rather than single amounts, subtract multiples of the number, as by now they should have a good knowledge of tables. So with this example, we would divide 50 by 5 first, as we know that 10 times 5 is 50. And 50 divided by 5 is 10. That leaves us to find out how many 5s there are in what's left, which is 22. And using my knowledge of tables, I know that 20 divided by 5 equals 4. If we take that away from 22, that only leaves 2, which can't be divided by 5. So that leaves the answer as 14, remainder 2. This method is sometimes referred to as chunking. It's not a new method, although many of us who came through the education system in the 70s and 80s will be more familiar with the bus stop method, which looks like this. Fives into 7 goes once, remainder 2. 5s into 22 go 4, remainder 2. And we get the same answer. The reason we teach the chunking method as opposed to this, at least to start with, is that it gives them a much better understanding of what they're actually doing, and also it's much more closely linked to how they would actually divide in their heads. In years 5 and 6, we continue to teach the chunking method with larger calculations. A good knowledge of tables is vital here. So in the example of 256 divided by 7, the children should know straight away that 210 divided by 7 is 30. Because they know that 7 3s or 3 7s are 21. If we then take that away from 256, that leaves 46. With a good knowledge of tables, the children will then divide 42 by 7, which is 6, because 6 7s are 42, and then that just leaves 4, which can't be divided by 7. So the answer, therefore, is 36, remainder 4. If the children had rapid recall of all their times tables by the end of year 4, they would find this, as well as many other areas of maths, a lot easier. This method can easily be applied to larger calculations, such as 6,738 divided by 8. If the children know their tables, they would realise that 6,400 divided by 8 is 800, because 8 8s are 64. That then leaves 338. Using their knowledge of the 8 times table, the most obvious chunk to use now will be 320, because 4 8s are 32. So 320 divided by 8 is 40. That then leaves 18. 18 is not in the 8 times table, but 16 is. So 16 divided by 8 is 2. Take that away, 2 left over, which will be the remainder. So the answer is 842, remainder 2. Or 0.25 if you're an able Year 6 child. Taught well and consistently throughout the school, with regular practice and recap, the children in my experience find this an easier method to use and become very good at using it mentally, especially to give an approximate or estimate of the answer. Most children, by the time they leave Year 6, can work out 256 divided by 7 in their heads with no need to write anything down. Moving on to long division, where they are dividing by 2 or more digits, again we continue to teach the children to use the chunking method. It is quite hard to use the bus stop method for long division. However, with chunking, the children would use multiples of 36 to divide that or break it down into chunks. With this kind of division, we would encourage the children to use their ability to multiply by 10 or 100, as well as their ability to double in order to break down the number into smaller chunks. So a child may think of 360 as being a good initial chunk because it's 10 36s, but a more confident child would hopefully put 720 down because it's 2 times 36, so 720 divided by 36 is 20. Take that away, that leaves 257, and the child can proceed from there. Sometimes, to avoid too many chunks, it can be useful to create a little table, in this example of the 36 times table over here, to help them to identify a near chunk. So, obviously, 1 36 is 36, 2 36s are 72, we can double that to get 4 36s, 144, double that again to get 8 36s, and then we can perhaps fill in the gaps by adding combinations of these together. So 3 36s will be these two added together, which is 108. I could then put down 5 36s, which would be a case of adding these two here together, which is 144, 174, 180. What haven't we got? 6. We could put 6 36s down, which would be a case of adding these two, which is 210, 216. 7 36s would be a combination probably of 4 and 3 36s, which is 252. That leaves, I think, 9 36s to work out. Different ways of obviously adding that up. I could possibly add up, for example, this one and this one, which would give me 324. So going back to 977, I still think I'd use 720 as my first chunk, which would be 20 36s. Haven't got room to write that in. Take that away from 977 and we're left with 257, and straight away I can see that 7 36s is going to be my next chunk. 252, take that away, there's only 5 remainder. So the answer is going to be 20, 27, remainder 5. That may well be quite a lot of effort for some children, and perhaps too time consuming, when it may actually be easier to use their ability to multiply 36 by 10, or if that was bigger, by 1,000 or 100, or as we said earlier, their ability to double 36 to 72. So many children, I think, would just choose 720 as their first chunk in this example, which of course is 20 36s. We take that away, we're left with 257. At this stage, children might do different things. A lot of children might, in fact, double and double again 36 to get 144. And 144 divided by 36 is 4. That then leaves 113, and they would then probably use 108 as their final chunk, because they can probably, by this stage in year 5 and 6, if they're tackling this kind of work, they're more than able to double, triple 36, and 108 is 3 36s. Take 108 from 113, and that leaves 5, which can't be divided by 36, so the final answer to 977 divided by 36 is 27, remainder 5. It's worth remembering that we would only move children on to long division when they're confident with short division. For those children really able and confident at short and long division using chunking, we would go on to show them how to use the bus stop method as a more compact alternative. This is the method that I certainly learned at school, and many parents will be familiar with. So we would look to see whether 7 goes into 2. It doesn't. So therefore, would 7 go into 25? Yes, it does 3 times, with a remainder of 4. Then we look at whether 7 goes into 46. It does 6 times, with 4 left over. With calculations involving more than one digit, in this case 36, the bus stop method is certainly a lot harder, but it's still achievable for children who are very good at mental maths. So here, 36 won't go into 9, but it will go into 97, twice of course, because that's 72. That leaves 25, which we squeeze in there, and then we have to look at how many times 36 goes into 257, which, with some working out, is 7, with 5 left over. That method may require the children to do some jottings and workings out somewhere else on the page.